Hello friends, this video on chemical bonding part 33 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 32. Explain the main aspects of the resonance with respect to CO3 minus 2. Let's explain this. So let's start with this. So I have carbon 4 electrons, oxygen 6 into 3 plus 2 negative charge. Total I have 24 electrons, valence electrons. So let's draw carbon and let's draw 3 oxygen here. So I start with 24. There are 3 bonds, minus 6 in bonds. I get 18. Let's make this carbon happy. Carbon had 1, 2, 3, 6. I give 2 electrons. Carbon is happy now. I have 16. 16 electrons I have each oxygen that needs 6 electrons. That means I need 6 into 3, 18 electrons, but I have only 16 electrons, right? That means there is a deficiency, so I'll do a double bond. So let's do a double bond here. Let's start from fresh. Let's do double bond here. Let's start from fresh. 24, there are 4 bonds, 8 electrons gone in bonds. We are left with 16. Carbon is already happy, 8 electrons. Let make this oxygen happy. This has 4 electrons, it needs 4 more. 12 electrons. 12 electrons we have. Each carbon, if we give 6 electrons, both will be happy. Right? So we have this structure. Minus 2 charge we can get. So this oxygen, how much charge? This will be 6 is the valence electron. Minus 6 electrons it has now, minus 1 bond, minus 1 charge. This carbon has 4 minus 1, 2, 3, 4, 0 charge. This oxygen has 6 minus 1, 2, 3, 4, 5, 6 minus 1. Again 6 minus 1, minus 1 charge. That is the minus 2 charge. But if you see, we could also create the structure in this fashion, right? Or in this fashion. That means there is a resonance here. Correct? There is a resonance here, or CO3 minus 2. Correct? So actual structure we can say is something like this. There is a resonance like this, and give it 2 charge. The question is, S3PO3 can be represented with this 2 structure. Can these 2 structures be taken as canonical form for the resonance? Let's see. I don't think so, because if you see here I have 2 OH, here I have only 1 OH, because the position of atom has been changed, right? The position of atom has changed, so we can't say that it is a resonance. It is not a resonance, because it is OH here, it is OH, it is OH. The position has changed. To write the resonance structure for SO3, NO2 and NO3 minus. See, for SO3 we get something like this, or we can get something like this, O double bond here, or we can get something like this. Any of this is true. Correct? For NO2 I can have double bond with this oxygen, or I can have double bond with this oxygen. For NO3 minus, I'll have 1 double bond, either with this oxygen or this oxygen or this oxygen. Correct? So we have to use the Lewis symbols to show the transfer of electrons between the following cations and anions. So let's take the first one, potassium and sulfur. Potassium has 1 valence electron and sulfur has 6. So potassium will be eager to give 1 electron to sulfur to make it to maintain the stable configuration, and sulfur will be eager to take one electron. So in this case, I'll have potassium as plus charge. Sulfur will get 2 negative charge because sulfur will take 2 electrons from 2 potassium. This will be the structure. If we talk about calcium and oxygen, calcium has 2 extra electron, oxygen has 6 in the valence electron. So calcium will be eager to give these 2 electrons to oxygen. So it will become calcium 2 plus and oxygen 2 minus. Correct? Let's talk about aluminum and nitrogen. Aluminum has 3 electrons in the valence shell. Nitrogen has 5. So aluminum gives all this electron to nitrogen. Both will become stable. So aluminum will become Al 3 plus and 3 minus, and nitrogen will become 3 plus actually. Nitrogen will gain 3 electron, it will get 8 electron, and it will become 3 minus. And both are happy. And they'll form a ionic bond. The question says although CO2 and H2O are triatomic molecule, the shape of H2O is band, CO2 is linear. And we explain this based on the dipole moment. Using Vesper also we can explain, using dipole also we explain. We'll explain using both. You take carbon, this is the shape, CO2. There is no electron here in the valence shell. And the net dipole is 0. It is linear. We take H2O, so we have 2 valence, 2 lone pair here, hydrogen we have, hydrogen we have. The net dipole for this is here, and there is a dipole, it has some value, x, which is positive, right? And thus it is, if you see, it is bent and this is straight. Using Vesper also we can explain. Using Vesper, if you see, this is a case. This is a case for 2 lone pair plus 2 bond pair. So that means it is bent. Correct? What is the significance and application of dipole moment? So in heteronuclear molecule, actually, when we have this dipole moment, the polarization comes due to difference in electronegativity of the atoms, right? So because of this, one molecule, one atom acquires positive charge, other becomes negative, and thus the molecule is said to be dipole. Example, you have seen this HF also. This gets negative charge, this gets positive charge, right? So this is dipole here, and the product of magnitude of this charge and the distance between the center of positive and negative charge is called dipole moment of the molecule. It is a vector quantity represented by arrow with the tail pointing to positive and the head pointing towards negative. For example, in this case, I'll have something like this. This will be my tail, this will be my head towards negative. Correct? And this is generally the measurement of polarity of bond. It is helpful in calculating the percentage of ionic character in a covalent bond or in a molecule. Correct? So it is generally helpful in finding the ionic character in a molecule. What is electronegativity and how it is different from electron gain enthalpy? So as you have seen, electronegativity is nothing but ability of atom in a chemical compound to attract pair of electrons. So please note, this has to be in a chemical compound. It is not constant. I can't say that electronegativity of fluorine is X. I can't say, because it varies from compound to compound. It varies with which, what is the other atom with which this molecule is tied. Right? It varies. It is not a measurable quantity. It is only a relative number. But when we talk about electron gain enthalpy, this is nothing but energy required to form or remove electron or sorry, add one electron to a atom to make it an ion. It can be positive or negative. This can be exothermic or endothermic, depending on whether electron is added to it. And a particular element will have a constant value of electron gain enthalpy, and it can be measured experimentally. So this has a constant value. So I'm talking about oxygen. So oxygen will have a particular value of electron gain enthalpy always. When you talk about electronegativity, you can't say the value of electronegativity for oxygen is X, because it varies whether it is linked to hydrogen or sulfur based on the condition. So we have to explain the polar covalent bond. So if you see water, example of water, this guy will get slightly negative charge, slightly positive, slightly positive. Why? Because oxygen is more electronegative than hydrogen. So since it gets a charge here, I'm saying that this is a covalent bond, but still it's polar. It is not neutral. So it's a polar covalent bond. That's what it says. Most of the covalent bond has the ionic nature and vice versa. So it's a polar covalent bond. You have to arrange the bond in increasing order of ionic character. So ionic character is, say the ionic character is proportional to difference between electronegativity of molecules. Correct? So this is electronegativity. So the more the difference of electronegativity between these two atoms, the more ionic it is. Correct? So in this case both are same. Nitrogen, it has least ionic character. Then it comes SO2. Then comes ClF3. Then comes K2O, and the maximum is LiF. Because in this case the difference between lithium and fluorine electronegativity is huge. So more is the difference in electronegativity of the atoms in the molecules, more ionic the molecule will be. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.